Imagine something so powerful that even from billions of kilometers away, we can still detect it here on Earth. Now imagine this something being violently expelled by a black hole, a celestial body known precisely for swallowing everything around it. Contradictory, right? So get ready, because you're about to discover what relativistic jets are and why they emerge from a place where nothing should escape. Relativistic jets are extremely energetic beams of matter and radiation launched from the center of certain galaxies, where supermassive black holes reside. They travel at speeds close to that of light and can stretch across thousands, or even millions, of light years. But the question that intrigues science, and probably brought you here, is how can something be ejected from a black hole if not even light can escape its gravity? The answer lies in the accretion disk. Before being devoured by a black hole, matter enters this disk, a spinning structure made of gas, dust, plasma, and even stars. Friction within this disk heats the material to millions of degrees, generating absurdly strong magnetic fields. And that's where the mystery begins to unravel. Some of this matter, instead of being swallowed, is accelerated along magnetic field lines and ejected at high speed toward the black hole's poles, forming the relativistic jets. But don't think science understands everything. We still don't fully know why only some black holes produce these jets, nor how they maintain so much energy over such vast distances. And that's exactly the kind of mystery that turns astronomy into one of the most fascinating fields of human knowledge. If this topic held your attention until now, it's because you also feel that burning need to understand the universe, and if you want to keep exploring these. So, how do relativistic jets affect the very fabric of the universe? Do they simply blaze through space, or do they actually bend the dimensions around them? This question brings us to a deeper and far stranger phenomenon, the warping of space-time itself. To understand it, we need to go back to Einstein's theory of relativity. According to it, any object moving at a significant fraction of the speed of light experiences time dilation and spatial contraction. Relativistic jets, moving at nearly the speed of light, carry particles that literally experience time differently than we do. From their perspective, their journey across thousands of light years happens in a blink. But from our point of view, those jets stretch across the ages. And here's where things get weird. Near the base of these jets, where matter is compressed, gravity intensifies. This can cause the space around the jet to warp, similar to how black holes distort the space around them. That warping is not as intense as a black hole's event horizon, but it's measurable. Satellites like the Chandra X-ray Observatory have detected how these jets affect the radiation and temperature of the space around them, bending light paths and causing gravitational lensing effects. But could humans one day harness this warping effect? Could we travel alongside a relativistic jet to explore deeper parts of the universe? Some physicists believe that the structure of space-time along such jets might contain natural channels for energy and particles, essentially forming cosmic highways. It's all theoretical, but worth dreaming about. Now imagine this. You're in a ship, following the tail of a relativistic jet, watching space itself fold and stretch before your eyes. This isn't science fiction, it's science, still unfolding. And in the next episode, we'll uncover what these jets are doing to their galaxies. Are they helping to form stars, or preventing their birth entirely? If you're enjoying this journey, hit like, subscribe to the channel, and don't forget to join us in the next video. We're only scratching the surface of the cosmos. Questions with us? Subscribe to the channel and activate notifications, because in the next video, we'll investigate what happens to time and space around these relativistic jets. You won't want to miss it. See you there. In the previous videos, you discovered what relativistic jets are, how they form, and how they achieve such incredible velocities. But now it's time to answer another key question. What real impact do these jets have on the universe? Do they simply travel through space, or actually shape the galaxies they come from? The answer might change the way you think about cosmic evolution. Scientists already know that relativistic jets are true sculptors of the universe. As they pass through intergalactic space, they heat and disperse the gas required to form new stars. This means that a single jet, launched from a galaxy's core, can prevent the birth of billions of suns for millions of years. It's a natural mechanism that regulates galactic growth. But the opposite is also true. When jets collide with cold gas clouds, they can compress them, triggering star formation. This is known as positive feedback. The universe, therefore, isn't passive. It responds to the violent motions of its own structures. Want another jaw-dropping detail? Jets like those from the M87 or Centaurus A galaxies are so powerful that they reshape the form of nearby galaxies, pushing dark matter, rearranging star clusters, and interfering with local gravitational dynamics. On a cosmic scale, they are like massive brushes repainting the universe. And if these jets are so powerful, another question arises: could they affect Earth? Is it possible that one is headed toward us right now? The answer is more complex than it seems, and involves gamma rays, dormant black holes, and galaxies that might be aiming straight at us. If you want to know what would happen if a relativistic jet struck our solar system, don't miss the next video. We'll explore real consequences, risks to Earth, and the latest theories on the matter. Leave a like, subscribe to the channel, hit the bell icon, and share this with someone who loves the cosmos. Every episode brings new answers and even more questions to feed your curiosity. And now we reach one of the most intriguing questions in the series. What would happen if a relativistic jet pointed directly at Earth? Would we be destroyed? Could we survive? The answer requires attention and might surprise you. First, it's important to know that a relativistic jet is truly dangerous only if perfectly aligned with our planet. When that happens, it's called a blazar. These straight-line jets emit explosions of gamma rays, the most energetic radiation in the universe. If such a burst hit Earth directly, it could cause severe damage to our atmosphere, destroying the ozone layer and triggering large-scale genetic mutations. In an extreme scenario, it could be a real threat to life as we know it. But relax, the chances of that happening are extremely low. The universe is massive, and even though relativistic jets are long, they're narrow. Still, scientists constantly monitor galaxies with active black holes nearby. One example, Markarian 501, a powerful blazar, only 456 million light-years from Earth. However, what worries researchers the most aren't the known jets, but the ones we haven't detected yet. Supermassive black holes may be active in hidden galaxies, beyond our line of sight. And if a jet is already on its way, since it travels near light speed, there'd be no warning. It would just arrive. Here's a twist. Such events are incredibly rare. Earth has already faced gamma-ray bursts in the past, and survived. Some of them may have even influenced past extinction events. The bigger truth? The universe is as violent as it is beautiful. Understanding these phenomena brings us closer not just to science, but to our own cosmic fragility. We are not the center of the universe. We're passengers trying to decode it. If you enjoyed this journey, subscribe now to the channel, because we're diving deeper. What happens at the exact moment a black hole is born? Is there anything faster than light? Is dark matter real, or a mathematical illusion? Buckle up. The next plunge into the cosmos is about to begin.